I've got with me a bag of coins. There's a reason I've got with me a big bag of coins. I used to have a big bottle and the cat kind of knocked it over. So there I was, loads of coins all over the floor. So I started stacking them up. You pull out a handful of coins. They were in a couple of piles. I'm not sure how many I've put in each pile. And I just thought, I wonder if I take the smallest pile, and I kept doubling it. So now the other side is the smallest pile, so if I could double that. And I thought to myself, well, will it ever stop? Is there ever a stopping stack, or can I actually do this forever? And does it matter how many I started with and how many I put in each pile to start them with? What we've got is a board with a load of coins. We've got different numbers. How many coins do you want to pull out of the bag to begin with?
15.
How many do you want in each stack to begin with? Remember, I'm starting with 2 stacks. 3 in one and then 12 in the other one. So there's 3. Can somebody come up, take this pen and double the smallest stack? Okay. So now what have I got?
6.
And 9. So can somebody record this for me? All right, then what? Go on.
Double the smallest stack.
Double the smallest stack, which means you're going to do what?
Add 6 onto
Add 6 onto there. What will my result be? 12 and 3. Will it be 12 and 3? Or 3 and 12? Why did I say that?
the stack on the left is...
Right, so I'm keeping the left and the right stack separate. What will it go to next?
6 and 9.
6 and 9, and then it will go to 12 and 3 again. Now, that was a group of 15 coins, but you started with a 12 and a 3. Does somebody want to give me a different starting pair?
9 and 6.
9 and 6. All right, why do you say no?
It's because we just did 12 and 3 and we got 9 and 6 from that pair. So we just keep repeating ourselves.
Another pair of numbers then? 11 and 4. Okay, so 11 and 4 becomes in the next go?
8, wait. 7, 8.
Okay, and then what? Right. Okay. So after 14 and 1 it then becomes 13 and 2. Can you? 13 and 2, yeah. And then we've got 11 and 4, which is where we started. So what I'd like you to do is actually try this yourselves in groups.
9 and 1.
9 and 1, yeah.
2 and 8.
Yeah, 2 and an 8.
4
2 and an 8.
6.
4 and 6.
8 and 2 again.
Yeah. And then it goes back.
Yeah.
And it goes back.
4, 4 and 6.
11.
12
and 4.
Give maths.
Then 8 and what is it? 8 and 8.
Either way we go, but it's going to equal 18, isn't it?
Yeah. Let's do 17.
Okay, 17.
Okay.
So 16 and 1.
16 and 1.
Why are you trying prime numbers?
Well, we tried 7 and we noticed that it kept going in a constant loop with 4 different sets. So we thought if we could try all prime numbers, then if they might have that same pattern.
We thought that maybe the starting number would affect how many numbers are in stages, but then when we investigated again, it was the same. So we thought there was no point in
it's
looking
5,
at it
then it would
further.
be 5 combinations to make the
Right.
thing, but then we realised that that's 4 and that's 9. And
Okay.
Then on this one, we didn't go back to 9 and 2. We just
Oh no, they're 2 different things, aren't they? Yeah, so for all combinations have 4 stages.
Shouldn't we do one starting with 12 and 4 and 14 and 2?
that goes to 4 and
12.
Yeah.
And 8 and 8.
So that's 3.
Yeah.
But then there must be one
look,
before that.
it's this,
Yeah.
same as this, but it doesn't start with 7 and 9.
So that's happened there.
So that's happened the same as there. If it's even, then it only has 3 in, and if it starts with an odd,
Then it has all 4.
then it has all 4.
If the starting number is even, then it only has 3 stages, whereas if the
Yeah,
starting number is odd,
starting
then it has
2
4.
numbers are 4. Shall we try another
Do an
even square number?
Yeah.
Okay.
So what?
So I do a little-
36.
What I would like you to do is you're going to assess each other's work. And you can take a pen and highlight on the progression table where you think they've got to.
So these 2 are square numbers. These 2 are prime and triangle. So they're investigating the different types of numbers that we can work with.
Yeah.
Is that clear choice about mathematical features to investigate? Yeah. They're investigating prime numbers, square numbers, prime numbers.
So the top one.
Yeah.
Yeah, that's done.
Okay.
Recognises the even numbers of counters, produce more than one step in sequence. Well, they've used even numbers.
You have used under 4.
Yeah, that's the point. They haven't. So it's over 4, so yeah,
They have done it. Yeah, they have done that.
uses an effective method to work towards a solution that takes into account prime numbers and all powers of 2.
They've done that.
We've not done prime numbers.
They haven't done prime numbers,
They've gone up
but
to powers of 2.
they've gone up in 2. So well, there isn't any algebra.
There's no algebra, so
Okay, I think this one is.
they did it.
This is all you've got. Can you tell me what they've done?
They've worked kind of systematically within, with even numbers, going up in 2s.
Right.
From 10, because they thought that below 10 wouldn't be a big enough number to get enough exchanges from.
Have they written that 10 wouldn't be?
So,
They've written it on the side, okay. And what did they discover?
that when they hit doubles, you can't go any further, and that for one number, it's all the same amount of exchanges. So for 16, there will always be 4 exchanges.
Can you show me on the board the very furthest that they went with their work? What is that telling us about this piece of work?
They were good at representing and analysing it, but they weren't as good at evaluating it.
Evaluating and
Interpreting.
interpreting and...
Communicating and
But they were very good at actually doing the task and recording it, but maybe not so good at writing down any patterns that they noticed. So that's something then that maybe they can work on for next time. This was your work. Do you think that's a fair assessment?
Yeah, I do think it's a fair assessment because we worked more on finding patterns than, and we didn't so much reflect on what we'd done.
This group,
They went through numbers starting with 3, and then they labelled what sort of numbers they are. So, for example, they started with 3, which is a prime and triangular number, and then went up to 4, which is a square number, and then 5, which is a prime. And they started with like 1 and 2 for making 3, and then said that they swapped around, so they like described all the patterns that were happening in here. And then they said that when you get to a double, they will always end in 2 numbers. So if you had like 4, 8, 16 and possibly 32, you'd always end up with a double at the end. They wrote sort of an explanation down here, but generally it was like arrows and sort of just writing labels and stuff on the diagrams.
They're really good at evaluating it and summing it up.
Yeah, because when they did like find something that was out of the ordinary, they would label it and say they wouldn't certainly explain it, but they would notice. They would like write down something if they noticed if it was different.
They just did normal numbers, so they just did 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Because
up to 16.
when we sort of did it,
Okay.
if we found something that was different, we would start doing
A new
things and trying to investigate it. Whereas they sort of carried on in a line, but if they did find something that was different, they wouldn't sort of repeat it and try and figure out what it was.
this was your work.
Yeah.
What do you think?
Well, I totally agree with all of their comments, because but with what they were doing with their work, they said that they made it clear that they were talking about squares and then prime numbers, but we thought by doing it like starting with this lowest amount of coins, and then by getting bigger and bigger, and then colour coding it was like we put on there in green or something prime, and then triangular and square, and then by doing the arrows to show that they're swapping. So we knew what we were talking about, but obviously it was difficult for people to understand.